So, hello, a very good morning to all, and welcome again to my class. Okay, so this is the last session for this crash course, and I hope you enjoy a lot this course and you learn a lot of things from this crash course, right? So, I wish you all all the best to your exam. Okay, from tomorrow onwards, your exam is going to be start. So, I wish you all the best and do your best and rest all. Things going to be happen good, right? Okay, so today in our last class we are going to discuss metallurgy and surface chemistry, right? So today we are going to do some PYQ questions related to these chapters, metallurgy and surface chemistry, and at the same time just like the other classes we already did. I'm going to explain the concept whenever they need it, right? So let's start with the today class, that is metallurgy and surface chemistry. So this is the first question, and this is from metallurgy, right? So this is the match list with list two type of question, right? And this is, I guess, this question were coming in the last examination of JEE, right? So what the question asks, beta? According to the question, you have to match list one with list two. In the list one, some name is given like reverberatory furnace, electrolytic cell, blast furnace, and the zone refining furnace. Plus, and the list two, the name is given like pig iron, aluminium, silicon, and copper, right? Silicon and copper. So you have to identify for list one, you have to match the list one with list two, right? So for few names like electrolytic cell, zone refining furnace, you know this name very well, right? So by knowing these two only, you can predict what is the correct order for this question, right? So we know that electrolytic cell is basically used in what? That is for what, beta? That is B. B here stands for 4, right? The electrolytic cell basically used for the refining of copper, in which the impure copper is converted into pure copper. So first by using this, that is a that is a reverberatory furnace used for the roasting of copper. Electrolytic cell is used for the reactivity metal like aluminium, right? So electrolytic cell basically used for the reactive metal like aluminium, magnesium, all that. Blast furnace is used for the hematite to pig iron, and the zone refining furnace used for the semiconductor like silicon, right? Like silicon. Okay. Okay. So these are the correct. So what is the correct answer for this question, beta? Laboratory furnace used for the roasting of copper, electrolytic cell used for the for the reactive metal like aluminium. So just match this electrolytic cell, that is B stand for 2. That is B stand for 2 and A stand for 4. So A stand for 4, this one. So option A is absolutely correct for this question. I hope is it clear to you? And this thing must be remembered, right? This thing has to be remembered to you. Uh, if you remember this concept and if you remember this point, then you can easily solve a question related to this, right? That is, a laboratory furnace is basically used for the copper, electrolytic cell is used for the reactive metal like aluminium, and the blast furnace is used for the pig iron, and the zone refining is basically used for the silicon, right? So this is all about the question. Now, the metal which is extracted by oxidation and subsequent reduction from its ore is. So you have to identify the metal which is extracted by the oxidation and subsequent reduction. But at the same time by oxidation and by reduction from its ore. Then the name of the metal is. What is the name of the metal, beta? Yes, that is silver. How will it obtain, beta? When the when the oxidation of silver takes place, it will convert it into this, right? That is dicyanide and silver oxidation state having 2, right? Now they are converted with zinc, they become reduced also. So this is the conversion, this is the pure metal we obtained, right? So zinc is the metal, that is the metal which is extracted by the oxidation and subsequent reduction from its ore is what? Is silver, that is Ag. That is option number 2 is absolutely correct for this question, right? Now, which one of the following reaction does not occur during the extraction of copper? So out of this four option, you have to identify which one is the correct option. Yeah, which of the following reaction does not occur during the extraction of copper. So when we extract copper out of these four, which reaction will not take place, right? So we know that that is when the CuFeH2 plus O2, that is a partial roasting, right? So copper 2S FeO plus SO2, FeS is very small and copper oxide is very small, right? Now this CO2S plus there's a copper sulfide plus O2. This will gives us copper oxide plus SO2. That is no formation of calcium silicate in extraction of copper. Okay, so there is no formation of calcium silicate. That is option number 3. Just remember this option, beta. That is, there is no formation of calcium silicate in the extraction of copper, right? Are all other three reactions are taking place during the extraction of copper, but calcium silicate, right? Calcium silicate, there is no role of calcium silicate, and this reaction won't possible in the extraction of copper. So which option is, bit correct for this question? That is, which one of the following does not occur? That is the calcium silicate, right? So this reaction will not occur. That is the no formation of calcium silicate in the extraction of copper, right? Okay. Now, move to the next question. What the question asks, beta? That is the reaction representing the Mond process for the metal refining, right? That is the reaction representing the Mond process for the metal refining is what? NiCO, NiCO4, or we say that is a 2K AuCN2 plus zinc, or Zr plus 2I2 gives us ZrI4, or ZnO plus C gives us Zn plus CO. So you have to identify the reaction representing the Mond process. So it is a very important process, beta, Mond process. So just try to learn this process. Ki Mond process is used for the extraction of what, and in Mond process which reaction takes place, right? So that is the first one, right? That is the formation of carbonyl, right? That is when the nickel is treated with 4CO, then the formation of NiCO4 takes place. That is the tetracarbonyl nickel, right? Tetracarbonyl nickel. So the first reaction that is represent the Mond process. So just remember this, the reaction, and that is the reaction represent the Mond process for the metal refining. Okay, I hope is it clear. Always remember this whenever the metal carbonyl formation takes place, that is nickel carbon. Okay, now the next question is, beta, the major component of which of the following ore is sulfide base mineral? So out of this, you have to identify out of calamine, cedrite, malachite, and sphalerite, which one of the following is the ore that is a sulfide base mineral? As the name suggests, just observe carefully these four names. Okay, so try to guess the name, which is basically used for the sulfide base mineral, whether it is a cedrite or saffrorite, right? So, what is the correct answer for this question, beta? Yes, absolutely correct. That is the saffrorite, right? That is the calamite is an ore of carbonate. Siderite is the ore of FeCO3. Well, on the same way, Sphalerite is the ore of zinc sulfide from which you obtain sulfide, right? And malachite is the ore of a copper carbonate, copper hydroxide. Okay, so I hope this is clear. Sphalerite is an ore of what, beta? This ore is basically used for the sulfide base mineral, right? So the correct option for this question is sphalerite. Now, which one of the following statement is incorrect? So out of these, you have to identify the incorrect statement, right? So which one of the following statement is incorrect, right? So the first one is, that is, boron and indium can be purified by zone refining method. The first one is boron and indium can be purified by zone refining method, whether it is true or not, right? Next, move to the next point, that is, when Arcal method is used to purify the tungsten, right? That is when Arcal method is used to purify the tungsten. The third one is cast iron is obtained by melting pig iron with the scrap iron and coke using a hot air blast, right? That is, the cast iron is obtained by melting pig iron with a scrap iron and coke using a hot air blast. And the next one, that is, the malleable iron is prepared from the cast iron by oxidizing impurities in a laboratory furnace. So out of this, you have to identify which of the following statement is incorrect, right? Whether it is the first, second, third, or fourth. What is the first task, beta? That is, the boron and indium can be purified by the Joule refining method. We already studied in a last question, that is, Joule refining is basically used for the silicon. We are already studied, right? So that is this statement is absolutely wrong. That is statement number two. That is, a Van Arkel process is used for the purification of titanium, zirconium, HF, and B. Right. And here only given is Van Alker method is used to purify tungsten. So this is absolutely incorrect statement, right? Because the Van Alkel method on, and this point you must remember also better. Must be remember, that is what is the use of Van Alkel process. So Van Alkel process is basically used for the purification of titanium, zirconium, HF, and B. Okay, so this point you must be remember, that is what is the role of Van Arkel process, or what is the role of Van Arkel method for the purifications. Okay, so Van Arkel process or this method is used for the purification of titanium, zirconium, HF, and B, right? So I hope you are clear with this question. Okay, any doubt, beta, related to this question? No? Okay. Now, among the following compound, the number of those present in a copper mate is. So, out of this four option, you have to identify among the following compound the number of those present in a copper mate. Okay. So, out of this, which will be present in a copper mate, beta? That is copper carbonate, copper sulfide, copper oxide, yeah, FeO. That is a ferrous oxide. So you have to identify out of this four, which one is. That is FeS and copper sulfide present in a copper mate. Just remember this word, FeS and copper S, right? That is a B option. Yeah. And one more important note here. Also remember one important thing, that is copper and FeS. This both are present in the copper mate. Okay, so one important extra name also you must remember, that is FeS. This must be remembered. So FeS and copper sulfide, they both are present in a copper mate, right? I hope is it clear to you? Okay. Now next move to the next question, and this question is from surface chemistry. So we discuss about 9 to 10 questions related to the metallurgy part. Now we are going to discuss some question related to the surface chemistry, right? So what the first question is, beta? For the colloidal particle, the value of the colligative properties are of a small order as compared to the value shown by the true solution at the same concentration. This is the first statement. What the second statement state, beta? For the colloidal particle, the potential difference between the fixed layer and the diffuse layer of the same charge is called the electrokinetic potential, or we say zeta potential. You have to identify the which statement is correct. Now, let me tell one thing. If you're talking about the there's a three type of solution basically, right? One is known as true solution, right? One is known as true solution. One is known as colloidal solution, right? One is known as colloidal solution. And the similar basis, one is known as suspension, right? Suspension. Okay, so in true solution, basically it is a homogeneous mixture of two. Homogeneous mixture. And these two are the heterogeneous mixture. Okay, between the solute and solvent, right? So these are the homogeneous and they are the heterogeneous. In colloidal, the size is between 1 nanometer to 1000 nanometer. 1 to 1000 nanometer, right? 1 to 1000 nanometer, right? And similar, if I'm asking about the true solution, the size is less than 1 nanometer, and for the suspension, size is greater than 1000 nanometer, right? So these are the basic property. So now the first statement is that for the colloidal particle, the value of the colligative properties are of a small order. Basically, colligative properties are what? Colligative properties are basically used for the dilute solution, right? A small order as compared to the value shown by the true solution. मतलब बोल रहा है कि true solution का जो values होगा वो उससे comparison में कम या ज्यादा, right? So for the colloidal particle, whether it is a true or wrong, beta, let's see. right? So statement 1 states that for the colloidal particle, the value of the colligative properties are of the small order as compared to the value shown by the true solution at the same concentration. And this is absolutely correct, right? Now the statement 2, and it is a statement based question, it is a statement based line, that is, for the colloidal particle, the potential difference between the fixed layer and the diffuse layer of the same charges are called the zeta potential. So this is also true, right? But these are, but these are not the correct expression of each other, but both are true. So statement 1 and statement 2 both are true, right? So the correct option for this question is, that is third, right? So from here, try to learn the three things, that is, what is tree solution, colloidal solution, and suspension, in which the solid and solvent are present in a homogeneous or heterogeneous phase, and what is the range of the size, and what is called zeta potential. So these points must be remembered, right? Because maybe some question were going to be asked related to this topic only. Okay, now move to the next question, that is the number of a statement which are characterized by the physiosorption. So we know that there is a two types of absorption. One is known as physiosorption and one is known as chemiosorption. We know that in physiosorption, weak van der Waals forces are involved, where in the chemiosorption, some chemical bonds are involved. Physiosorption involve low heat of enthalpy like 20 to 40 kilojoule, where the chemiosorption involve large amount of energy, that is 80 to 240 kilojoule. Right. Physiosorption is also a multi-layer, where the chemiosorption is only mono-layer. So these are the some important points of difference between the physiosorption and chemiosorption. Now, in this question, the number of statement which are in the characteristics of physiosorption. First one is, it is highly specific in nature. Okay. Enthalpy of absorption is high. So this is not true, right? Because in chemiosorption, enthalpy of absorption is high. It decreases with increase in temperature. So physiosorption, it decrease with increase in temperature. So is it true? Yes. Is it true? It decreases with the increase in temperature, because as we increasing the temperature, the the molecule going far away from the surface, and their absorption decreases. So this one is also correct, right? So this one is also correct. It results into the unimolecular layer. Wrong, because it is a multimolecular. We know that chemiosorption is unimolecular, not physiosorption. No activation energy is needed. And the first is, it is highly specific in nature. Whether it is highly specific in nature or the chemiosorption, obvious it's a chemiosorption, right? So only 2 points, that is decrease with increase in temperature, right? Decrease with increase in temperature. This one is correct. And no appreciable activation energy is required. Okay. And which are the number of statements which are the characteristics. It results into a unimolecular layer. So this is wrong. So this is also wrong. So only 2 points. This is first and last. These 2 points. That is the no activation energy is needed, and it decrease with the increase in temperature. So only these 2 points are right. The rest all points are the point of chemiosorption. If the question is like this, the number of statement which are the characteristics of chemiosorption, then how many points are correct, beta? Yeah, tell me. If the question is for chemiosorption, then how many points are correct out of these 5? The first point is correct, that is, it is highly specific in nature. Second point is also correct, that is, the enthalpy of the absorption is very, very high. And the third point is also correct, that is the result in the unimolecular layer. So the correct answer is 3. Okay. So in chemiosorption, the correct points are 3. But in this question, they are asking about the physiosorption. The physiosorption, only 2 points are correct out of this 5. I hope is it clear to you? Okay. Okay. Any doubt better related to this question? Any problem? No? Okay. Now, let's move to the next question. That is the number of incorrect statement from the following, right? You have to identify the number of incorrect statement from the following, either or maybe one or two. First, the water vapor are absorbed by the anhydrous calcium chloride. Whether the water vapor are absorbed by the anhydrous calcium chloride or only calcium chloride. Okay. Let's see the second option. There is a decrease in the surface energy during the absorption. So whether there is a decrease in the surface energy during the absorption. Next, as the absorption proceed, delta H become more and more negative. So as the absorption proceed, means as the absorption is starting, delta H become more and more negative. Okay. So we all know that absorption is an exothermic phenomenon, right? Absorption is accompanied by the decrease in heat. Let's see the full question. That is first one is that is a water vapor is absorbed by the calcium chloride, not the calcium hydride, calcium anhydride, right? And the C is also correct. As the absorption proceed, delta H become less and less negative. So these two are the incorrect statement. That is, as the absorption proceed, delta H become more and more negative. This is not the correct, right? So only these two, that is A and C, are incorrect statement. Rest all are correct, right? So this is for this. Now, the next question is, which of the following salt solution would coagulate the colloidal solution formed when the FeCl3 is added to NaOH solution at the fastest rate? So we know that what is coagulation, right? Coagulation means kya beta? Coagulation means what? When the stability due to the charge differences, right? So which of the following salt would be coagulate the solution formed when the FeCl is added to NaOH? So you have to add FeCl to NaOH solution at the fastest rate. So just calculate the number of ions of each, right? In AlCl3 they having how many ions beta? If I'm talking about the positive ion, that is positive ion having in AlCl3, Al having plus 3 number of ion and chlorine having -1, right? So it having a positive 3 and a negative only 1. Na2SO4 again 2 Na plus, and this is NO4 twice negative. Calcium phosphate again plus 2 and PO4 having plus 3 charge, right? That is -3, right? Okay. Now calcium chloride again, calcium having plus 2 charge, chloride having -2 charge. So out of this negative, which of the following having more negative charge? That is a PO4, right? That is a PO and 4. So solution formed is negatively charged solution. Therefore, aluminum has the highest coagulating power. We know that because the solution is what? FeCl3 is added to NaOH. So whenever the FeCl3 is added to NaOH, right? Okay, so which of the following salt solution would be coagulate the colloidal solution formed when the FeCl3 is added to NaOH solution at the fastest rate, right? So we know that for the negative solution, right? For the negative solution, coagulating power is how we measure the coagulating power? The cation having the more charge, right? The cation having the more charge, the cation having the more charge, having they coagulate the negative solution, right? And similar for the positive solution, the anion having the negative charge which coagulate more easily. So from all above, we know that calcium having +2, calcium having +2, sodium having +1, aluminium having +3. So since the solution is negatively charged, so out of this, which one will use? That is the aluminium, because in aluminium it having +3 charge, and we know that for negative solution we use the cation, and the cation which having more degree of charges now, they are preferred, right? So the correct option for this question is A, and this is called what rule beta? Hardy-Squiz rule. Hardy-Squiz rule. Similar, I'm giving one explanation. If someone asks, the question is like, if someone asks, I want to coagulate, I want to coagulate chlorine negative. Okay, so chlorine negative. If you want to coagulate this chlorine negative, then you want positive charge. So just tell me, out of sodium, magnesium, and aluminium, which one is more effective beta? Because I want to coagulate negative charge. So for negative charge, which one is more effective beta? That having more positive charge, that is aluminium. So aluminium having more coagulating power. So this rule was given by Hardy-Squiz rule, and this is basically used to calculate and used to find the coagulating power of the cation, right? So just remember this. Now, given below are the two statements. One is labeled as assertion and the other is labeled as reason. So what the assertion? In expensive scientific instrument, silica gel is kept in the watch glasses or in a semi-permeable membrane bags. So assertion one state that in expensive scientific instrument, okay, silica gel is kept in watch glass or in a semi-permeable membrane bags. Reason: silica gel get absorb moisture from air via absorption thus protect the instrument from water corrosion, rusting, or prevent malfunctioning. In the light of these two statements, which one is correct and which one is the good explanation of each other, right? So you have to identify. So option 3 is absolutely correct. That is, the silica gel prevent water corrosion, rusting, and instrument malfunction by absorbing moisture from the air. So both A and R are true, and R is the absolute correct explanation of it, right? So that is the use of silica gel. Okay, so in any expensive scientific instrument, silica gel is kept in the watch glasses or in a semi-permeable membrane bags. And why this is? Because learn this point from here also, because maybe questions will going to be asked from this topic related to only, right? Silica gel having a absorb capacity. So silica gel absorb moisture from air via absorption, thus protect the instrument from the water corrosion, rusting, or preventing malfunctioning. In the light of this, both statement, that is statement A and R are true, and R is absolutely correct explanation of it, right? So this is all about. Now move to this question, and this one is going to be very interesting question, right? That is the this basically question from Friendlich isotherm curve. So this is going to be interesting. How to calculate this? Let's discuss. So graph of log x by m versus log p for an absorption process within a straight line, inclined at an angle 45 degrees with intercept equal to 0.6020. The intercept is given. The mass of the gas absorbed per unit mass of the absorbent at a pressure of 0.4 atm is this. You have to identify this value, and log 2 value is already given. So we know that uh, absorption isotherm, that is this is the graph between log p and the log x by m. This is called the intercept. So we know this statement, right? We know the equation, that is log x by m is equal to log k plus 1 by n into log p. So it is already given the slope is 45 degree, right? So 1 by n comes out to be 1. Okay, so it is already given now 1 by n, that is 1045 degree. So 1 by n is equal to 1045 degree, which is the slope, and it comes out to be 1. So n values comes out to be beta 1. Now log k is also given. Log k is what beta? Log k is 0.6020. So we know that k comes out to be 4. Okay, so this is the value of log 4. Okay, so this is the value of log 4. So log k is equal to log 4. So k is equal to 4. Now x by m is equal to kp raised to the power 1 by m. So we know that this is x, this is m. We know that k is what beta? We already calculated, that is 4. What is p beta? 0.4. And what is 1 by n? 1 by n comes out to be 1. Right? 1 by n is equal to 1. We already calculated. So just putting the value, what we get beta, that is 1.6, right? That is 1/6 into 10 ki power minus 1. So the correct answer is 1/6, right? That is the 16. So 16 into 10 ki power minus 1 is the correct answer for this question. I hope, is it clear to you? How will you calculate? It's very simple. Just remember this formula, right? Just remember this one simple formula. If you know this formula, then you can easily calculate the value, because in this question so many hints are given. They're like slope is 45 degrees, so from here we calculate 1 by n, which comes out to be 1, and log k is also given 0.6020. So from here we calculate k, and k comes out to be 4, right? And the x by m is equal to kp raised to the power 1 by n. So just putting the value, you'll get the value of x by m, that is 1/6 into 10 ki power minus 1. So the correct answer for this question is 16. Now, on the same basis, another question is going to ask beta, in the given figure, a straight line is given for the Friendlich adsorption y is equal to mx plus c, right? Mx plus c means what is this beta? This is the slope, okay? So this is the slope. Here the slope is equal to 3. So we know that 1 by n is equal to 3. So what is 3 beta? N is equal to 1 by 3, right? N comes out to be 1 by 3. So 1 by 3 means what beta? That is 0.3. And so first thing is clear, 1 by n. And is we can find n, right? And the value of 1 by n. So what the value of 1 by n is what beta? 3. The value 1 by is 3. So out of these 3, this option is neglected. These two. So out of 3 and 4, one option is correct, right? Let's see the which out of these two are correct. So the first thing is very much clear. That is how we calculate n. So we can calculate n is equal to 1 by 3 because we know that now y is equal to mx plus c, straight line equation. Y is equal to mx plus c. So from here we can calculate the slope like m. M is called slope. By just comparing these two equations, now we can calculate the n. Right? Now you have to calculate the log k. So we know that for this we also know the formula, that is x by m is equal to kp by 1, or we learn simple formula like log x by m is equal to log k plus 1 by n log p. So we know that what's the value of this beta? We know that y is equal to 3x plus this, right? And 1 by n is equal to 3. So what is log k? So log k comes out, we just comparing this equation, right? So we know that y is equal to mx plus c. Just I'm writing here also. Y is equal to mx plus c. Just comparing this. On the y-axis, we have a log x by m, right? And this is, sorry, is equal to, for m, we have a 1 by n and log p, and for c, we have a log k, right? So just comparing this. So we in the question also it is given this is y, and this is this is the 1 by n is equal to 3, right? So this is also given, that is 3. This is x, 3x plus 2.505. So from here, y is equivalent to this, 3 is equivalent to this, x is equivalent to this, 2.55 is equal to this. So log k is equal to 2.505. So it is very simple question, right? Just if you learn the formula, that is log x by m is equal to log k plus 1 by n log p, then you are going to solve this question in a such easy way. So please remember this concept as well, right? Because maybe some questions are definitely going to become from this topic alone. Okay. So is it very much clear? So which option is correct, beta? Yeah, that is option number 3. So option number 3 is absolutely correct. That is 3 and 2.505. So these are the correct statement for this question. And it's a very simple question, everything is given. You just have to compare this with that is the log x by m or 1 by n log p and the log k, right? If you know this only, then you can solve this question within a 10 seconds. Now, the next question is, now this question is also from the, metallurgy chapter. So let's discuss this question. So the first one is that is sulfurite, calamite, galena, and citrite. So for this, which of the following? So you already know that the sulfurites are used for the zinc sulfide. We already discussed this question, right? So A is equivalent to 4. So in which option? Yeah, we have two options. So just cut the last two options because in this there is no A match with 4. So these two are the incorrect. So out of this A and B, you have to identify the correct. Now, the next is calamine. So calamine is basically used for the which one? Calamine is basically used for the which ore? And the galena and the citrate. So we know that citrate is used for the which beta? That is the carbonate, right? So citrate is used for the carbonate. The D is equivalent to 1. So the correct option is A, because A is equivalent to 4, and B, that is a calamine. Calamine is equal to zinc carbonate. Similar C, that is a galene, is equal to PBS, and the citrate is used for the FeCO3. So as you observe, we discuss one question, right? So on that question, by using the concept of this question only, you can able to do this question as well, right? So if you know the one question, then you can easily, on the basis of same criteria, you can able to solve more question as well, right? So I hope is it clear to everyone, that is what is the correct option for this question. Right. So this is the absolutely correct answer for this question. That is option number A. Okay. So option A is the correct. So just remember this. Because last question will come in the 2023, this year only, Jan. And this question is from 2022 June exam. So just try to, relate this thing. These two questions are almost same. Okay, if you know the 2022 question, then you can easily solve this question also. That is in 2023 Jan month paper, right? So just by doing this now, you can also learn maybe in your come in examination. Some questions were coming related to which ore is used in a galena or citrite or calamine. So just remember this point. Right? It will going to help you. Now, which of the following chemical reaction represent the Hall-Hérold process? So you have to identify out of the following, which of the following chemical reaction represent the Hall-Hérold process, right? So just identify which of the following chemical reaction represent the Hall-Hérold process, whether it is a chromium trioxide plus 2 aluminum, yeah, aluminum trioxide with carbon, or ferrous oxide with the CO, or with the street complex with the zinc sulfide. So you have to identify. So we know that the Hall-Hérold process is the major industrial process for the extraction of aluminium. So just remember this point, beta. Hall-Hérold process is the major industrial process for the extraction of aluminium. So which one is correct, beta? Yes, that is the B. So always remember this. That is the Hall-Hérold process is basically used for the manufacturing of aluminium only. Now, the next question is beta, that is the pyrite, galena, zinc blend, and the copper pyrites. How many of these minerals are sulfide ore? Again, the questions are asked from this topic only, right? So these questions are going to be asked again and again and again. So out of these, four, pyrite, galena, and zinc blend, and the copper pyrites, how many of these minerals are sulfide base? So you have to identify the sulfide base. So we know that is a pyrite, Pyrite contains sulfate ore. So this is not. Now galena PbS, zinc blend ZnS, and copper pyrite copper FeS2. Okay. So these three, right? These three are, that is whether it is a galena or a zinc blend or a copper pyrite. These all three are sulfide ore. Okay. So just remember this. These are the sulfide ore. Okay. So out of these four, galena, zinc blend, and copper pyrite, they are the examples of sulfide ore only. Okay. I hope is it clear to you? Right. Now, leaching of a gold with the dilute aqueous solution of NaCN in presence of oxygen give complex A, which on reaction with zinc form the elemental gold, and another complex B. What is A and B respectively? So you have to identify the A and B. So we know that when the gold is treated with NaCN, now, then the formation of NaAuCN2 complex takes place. Now, when this complex is treated with zinc, then the gold formation plus this complex takes place. So this is our B and this is our A. Okay. If you write the name now, then the name become here this name is become sodium, that is sodium, and this is dicyanide. So this is sodium dicyanide, and for gold, okay, so rate oxidation number comes out to be 2 and 1, that is 1. Right. So this is the name. Don't go with the name because this name we are going to, write the name in a coordination complexes, right? For the coordination complexes, we know how to write the name of the complex, right? So on the same basis, I write this name. Now, so according to this question, what they asked beta and what the correct answer for this question, that is the formation of what? That is the AuCN, AuCN2 and Na2. The correct option is absolutely C. That is AuCN2 and ZnCl4 twice negative. I hope is it clear to you? Okay. Now, the next question is the statement wise question. It states that during the electrolytic refining, blister copper deposited precious metal. Okay, during the electrolytic refining, blister copper deposited precious metal. Statement 2 state that in the process of obtaining pure copper by the electrolysis method, copper blister is used to make the anode. Which of the following statement is true, whether first or second? So we know that in the electro refining, impure metal, here is the blister copper, is used as an anode, while the precious metal like AuPt, EgT get deposited at the anode mud. So we can say that both statement 1 and statement 2 are absolutely true, right? For electrolytic refining blister, here what is the meaning of blister copper? That is a bit of impure copper. Impure copper. So here the meaning of blister is impure copper. And during the electrolytic refining, blister copper deposited precious metal. And according to statement 2, in the process of obtaining the pure copper by the electrolysis method, copper blister is used to make the anode, right? So both the statement 1 and 2 are absolutely true. Now you have to match this. That is the concentration of gold ore, leaching of alumina, froth stabilizer, and blister copper. So which reagent you use for the following, right? Whether we use aniline, when we use NaOH, when we use SO2, and when we use NaCN. Okay, so you have to identify the following. So we know that concentration of gold ore, we generally use NaCN, right? We discussed in the last question itself. So for A, the correct answer is 4. So out of these four options, these two, so just neglect this. This trick is very important to solve MCQ question, right? Try to, fix one thing and cancel rest all. It means option elimination method. So by this you can also solve this question in a lesser time. So out of these two, only one is true, right? So B, that is the leaching of alumina. So leaching of alumina where SO2 is or NaOH is used. SO2 use or NaOH is used, beta? Yes, obvious, it's NaOH is used, right? So which of the following is the correct? Yes, that is this one. Because in this, the third, that is SO2. No, in the leaching of alumina, NaOH is used. So correct option is B. So for, A is equivalent to 4, that is A, any concentration of gold ore, we use NaCN. Similar, for leaching of alumina, we use NaOH. Now, froth stabilizer, example of froth stabilizer are aniline. And the blister copper we use third, that is SO2. So blister copper we use SO2. So these are absolutely correct answer. Now, in the metallurgical extraction of copper, following reaction is used. That is FeSiO4, that is ferrous silicon silicates, right? FeO and ferrous silicate respectively are, whether they are a gangue or flux, whether they are a flux or the slag, or they are the slug and the flux, or a gangue and the slag. So that is the D. That is FeO act as a gangue and ferrous silicates act as a slag. So just remember this. Silicon means slag. Okay, silicon means slag and the FeO is a gangue. Okay, so this one is the correct. Now, the next question is, in the isolation of which one of the following metal from their ore, the use of cyanide salt is not commonly involved. Okay, so in the isolation of which one of the following metals from their ores. So if you want to isolate the metal from its ore, the use of cyanide salt is not commonly involved. For which of the metal? Zinc, gold, silver, and copper, right? So it is for, right, zinc. For ZNS, KCN is used as a depressant for the gold and silver leaching or cyanide process, right? For gold and silver leaching or cyanide process. So the correct answer is ZNS, right? That is a jet copper. ZNS, KCN is used as a depressant, not. Okay. So the correct answer is copper for this question. Now, again, this question is coming, and this is, similar to the previous question we already discussed. That is the citrate. Citrate is basically used for what, beta? This is for zinc sulfide, right? And the sulfurite, we know that sulfurite, that is used for what? That is, whether it is FeCO4, right? So this is for calamite. Calamite is for zinc carbonate, right? Calamine for zinc carbonate. Ferrite means whether it is for FeCO3, yeah, melamine. So just the correct answer for this question is, we know the citrate is FeCO3, malachite is copper, this calamine zinc carbonate, and sulfurite is ZNS. So sphalerite is ZNS, right? Sulfurite is ZNS. Okay, so this is the correct option for this question. So just remember the name of this ore also, because many times the questions are asked related to the match type of question, which you have to match the correct element with their correct name, right? Now this question is from again surface chemistry. And what the question asks, beta, given below are the two statements. The statement one are, emulsion of oil in water are unstable and sometimes they separate into the two layers on standing. So they're saying that emulsion of oil in water, there is a two type of emulsion, right? The first one is oil in water and the next one is water in oil. In this, water act as a dispersed phase, and in this the oil act as a dispersed phase, right? So emulsion of oil in water are unstable and sometimes they separate into the two layers on the standing. Experiment 2, for the stabilizer of an emulsion, access of electrolytic is used. So identify the correct statement, right? So C is absolutely correct. What C states that beta, a statement 1 is correct, but the statement 2 is absolutely incorrect, right? So statement 1 is correct. Why? Because it is a fact and we know that the emulsion of oil in water are unstable and sometimes they separate into the two layers on standing. Whether the statement 2 are absolutely incorrect. That is, the principle of emulsifying agent for water in oil emulsion are proteins, gums, natural and synthetic soaps, right? Not the electrolytic, or we say not through by electrolytic acid, right? So statement 1 is correct and statement 2 is false. So correct option is C for this question. Now, when 200 milligram of 0.2 molar acetic acid is shaken with the 0.6 gram of wood charcoal, the final concentration of acetic after the absorption becomes 0.1 molar. Now you have to calculate the mass of acetic acid absorbed per gram of the carbon. So you have to calculate the mass of the acetic acid that is absorbed per gram of the carbon. So we know that the wood of the charcoal is given, that is 0.6 gram. Now, mass of the acetic acid observed is equal to M1V1 minus M2V2 upon 1000 into 62. This is the general formula for calculating the mass. Now, on putting the value, you'll get the mass is equal to 1.2 gram. Now, what is the mass of acetic acid absorbed per gram? So, total weight of the charcoal is 0.6 gram. So, 1.2 upon 0.6, that is 2. So, per gram, that is mass of this use is, right? I hope it is clear to you. Okay. Now, you have to identify the incorrect statement for the Tyndall effect, right? So, the refractive indices of the dispersed phase and the dispersed medium differ generally in the magnitude. The diameter of the dispersed particle is much smaller than the wavelength of the light used. During the projection of moves in the cinema hall, Tyndall effect is noticed. Yes, this is correct. And it is used to distinguish the true solution from the collider solution. Yes, you can also say that because the true solution, in this, the scattering of light does not take place, but in the collider solution, the light gets scattered, right? So these last two statements are absolutely correct. Okay. So the incorrect statement regarding this one is the incorrect statement because these all are the correct one. A, C, and D, these all are the correct one. Only one incorrect statement, that is B. That is the diameter of the dispersed particle is much smaller than the wavelength of the light. Now again, question is coming from the same topic. That is the 2 gram of hydrogen gas is observed on the 2.5 gram of platinum powder, and the volume of the gas observed per gram of the absorbate. So we know that volume of the gas, that is, we know that PV is equal to nRT, right? PV is equal to nRT. So what is V here? V is equal to nRT upon P. So we know the value of nRT upon V. Just put, we get the 24,900 ml. So the gram of platinum uses this upon 2.5 ml of H2, that is 9960. So this is the correct. Now, in the next question, the list one match with the list two type of question. In the list one, the lyophilic colloid emulsion positively charged and negatively charged. So liquid colloid, protective colloid. Okay, protective colloid and the FeCl3 plus NaOH and FeCl3 plus hot water. You have to choose the correct one. We know that protective colloids are lyophilic colloids. First one is protective colloid are lyophilic colloids. Okay, so protective colloids are the lyophilic colloids. Emulsion or liquid in liquid colloidal solution. FeCl3 plus hot water form positively charged colloid. FeCl3 plus hot water form positively charged colloid and hydrated of ferric oxide. Similar FeCl3 plus NaOH form negatively charged colloid solution due to the preferential absorption of OH ion. So which one is correct, beta? FeCl plus NaOH form negatively charged colloid. So FeCl and NaOH, this will form negatively charged. We already discussed this type of question. This will form positively charged. And this one is lyophilic protective colloid. And this is the emulsion. Okay. So just match this question. You can get the answer for this question, right? Now, this question is also very important. And this question is from only surface chemistry, right? So the given diagram, if the initial pressure of the gas is 0.03 atm, right? If the initial pressure of the gas is 0.03 atm, the mass of the gas absorbed per gram of the absorbent is what? So we know that X by M again is equal to Kp. This we know the formula. We already solved two numerical on this formula. So from this graph, we know the slope comes out to be 1 and the log K is also given, that is 0.602. So K is equal to 4. So just put the value, that is X by M is equal to 4 into 0.03 raised to the power 1 by 1. So you can calculate X by M comes out to be 12 into 10 ki power 2. So the correct answer is 12 here. Okay, so the correct answer is 12. Okay, so I hope is it clear to you? That is the correct answer is 12. How 12 comes? Okay, so from last 2 years, 3 or 4 questions are coming only from this topic, that is adsorption isotherm. So just try to learn this formula, that is log x by m is equal to log k is equal to 1 by n into log p. This one is a very important formula, and many times question are going to ask from this topic only, and this is one of the simplest topic, I say, right? Okay. Next question. The zeta potential is related to which property of the colloid? Color, Tyndall effect, charge on the surface of the collider particle, or the Brownian moment. As the name suggests, zeta potential. So it is absolutely related to the charge. That is the potential difference between the fixed and the diffuse layer of the charge in a collider particle is called zeta potential, right? So the option C is absolutely correct. Now, out of this, you have to match list 1 with list 2. There is a negatively charged salt, macromolecular colloid, positively charged colloid, and cheese. Okay, so out of this, CDS solution is starch, a gel, and Fe2O3. You have to identify the following. So we know that negatively charged salt is CDS, right? This is the negatively charged salt. Similar macromolecular colloid is starch, and the positively charged salt is Fe2O3 dot X2. And the example of cheese is gel. This is an example of water in oil, right? So this is a gel. So these are the correct. That is option number C is absolutely correct answer for this question. Okay. Now, you have to identify which of the following is the correct statement. That is the Brownian movement destabilize the sol. Any amount of dispersed phase can be added to emulsion without destabilizing it. Mixing two oppositely charged sol in an equal amount neutralize changes and stabilize collide. Or we say the presence of equal and similar charges on the colloidal particle provide stability to the colloidal solution. So out of this, only D beta, right? So as the equal and similar charges particle will repel each other, hence they will never precipitate, right? So only D, that is the out of the following, which is the correct statement beta, that is D. So I hope we are covering all the important, already covered all the important PYQ of the surface chemistry and the metallurgy, right? So I explain and give every type of revision for the such type of questions were generally asked in your examination. So I hope you understand this topic, understand the session, and please try to learn this, especially if I'm talking about the French-Ward isotherm curve now. Many questions are coming only from this equation itself. Okay, so just try to learn this equation. It's very useful for you, and you will able to solve the numerical coming on this topic. Okay, so I wish you all the best for your exam, and I just keep calm and just give your exam in a cool mind, and you can perform very well. You all have a very good potential, and I know you all can do much better. So again, I wish you all the very best for your tomorrow exam, and let's just give and just revise the whole concept. Don't take too much tension, just revise the concept, just utilize and just remember the formulas, like from which chapter we learn, try to learn some formulas, important note, just revise it, right? Don't do any new thing right now, just revise the previous summary, summarize all things, and just try to remember all these things. Okay, and really it's going to be a good paper, right? So let's end the session with this only, and again wish you all the very best.